Hello and welcome to Selection with Sathi. Today we dive into decorators and closures from Fluent Python Chapter 9. We will cover variable scope, closures, how decorators really work, functools.wraps, parameterized decorators, re_cache, and single dispatch. These are essential topics for Python interviews and advanced development. Let's start with variable scope. Python resolves names using the LEGB rule: local, enclosing, global, built-in. Local means variables defined inside the current function. Enclosing refers to variables in the outer function of a closure. Use the nonlocal keyword to modify an enclosed variable, and global to modify a modulable variable from within a function. A closure is a function that retains access to free variables from its enclosing scope, even after the outer function has returned. The inner function captures the variable, not just its value. These captured variables are stored in the function's __closure__ attribute as cell objects. To modify a captured variable, you must declare it as nonlocal. Decorators are syntactic sugar. Writing @decorator above a function definition is the same as calling f equals decorator of f. A decorator receives the original function and returns a replacement, usually a wrapper. An important detail: decorators run at import time, meaning the decorated function is replaced as soon as the module is loaded. functools.wraps is critical for well-behaved decorators. Without it, the wrapper function replaces the original's __name__ and __doc__. Apply @functools.wraps of func to your wrapper function. It copies __name__ __doc__, __qualname__ and __module__ from the original. This is essential for debugging, introspection, and the help function. Parameterized decorators use a factory pattern with 3 levels of nesting. When you write @decorator with arguments, Python first calls the factory, which returns the actual decorator, which then wraps the function. So you have factory takes args, returns decorator, decorator takes func, returns wrapper, wrapper handles the call. The factory captures its arguments in a closure. functools provides two powerful decorators. re_cache with memoizes 128 memoizes function results, caching return values based on the arguments. Arguments must be hashable for this to work. Single dispatch creates a generic function that dispatches to different implementations based on the type of the first argument. You register specialized versions with @func.register of the type.
Let's build a clock decorator that measures execution time. Import time and functools. Define clock that takes func. Inside, define wrapper with @functools.wraps of func. Record the start time, call the function, computes the elapsed time, and print the function name with the duration. Decorate any function with @clock and it prints how long it took. A registration decorator collects functions into a registry. Create an empty dictionary called registry. The register decorator adds func.__name__ as key and func as value, then returns func unchanged. Decorate spam and ham with @register. Now registry contains both functions, useful for plugin systems and command handlers. The classic example for _cache is recursive Fibonacci. Without caching, fib of 30 makes over 1,000,000 redundant calls. Add @_cache with maxes is 128 above the function. Now fib of 30 returns 8,32,040 instantly, each value computed only once. The cache stores previous results and returns them for repeated arguments. Singledispatch lets you create type-based dispatch without if-elif chains. The base function handles the default case. Register an int handler that shows the number with its hex representation. Register a list handler that wraps each item in HTML. When you call HTMLize of 4.2, it dispatches to the int version automatically. When you stack decorators, the order matters. @sign D1 @sign D2 definite f is equivalent to f equals D1 of D2 of f. D2 wraps f first, creating the inner layer. Then D1 wraps the result, creating the outer layer. When you call f, the execution goes D1 wrapper, then D2 wrapper, then the original f.
Important tips to remember. Closures capture variables by reference, not by value. Be careful with loops. Always use functools.wraps to preserve metadata. _cache only works with hashable arguments, no lists or dates. Decorators run at import time, not at call time. For parameterized decorators, remember 3 nesting levels: factory, decorator, wrapper. For more concept videos like this, download the Selection with Sathi app. Like and subscribe. Thank you.